Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 5.5 in the Nelson Advanced Functions textbook labeled Solving Rational Inequalities. If you guys are looking for more videos for advanced functions, feel free to take a look at our channel. We have a playlist with every single lesson from the textbook. And if you are somebody who's looking for tutoring, feel free to click the link in the description below, and our team would love to get in contact with you. But without further ado, let's get straight into it. So solving rational inequalities. Last lesson in 5.4, we did solving rational equations, which was all about solving for x. But in solving rational inequalities, we are going to be doing things with inequalities. So it's very similar to linear inequalities we did in the previous unit, but rational inequalities we're doing with fractions. So let's look at this. Let's start off with just some examples. We're just going to bang some of these out. So let's say you have an equation that says x plus 3 over x plus 1 is greater than or equal to x minus 2 over x minus 3. Okay, so the first thing is we have to solve it. But notice this is an inequality. This is what makes something an inequality. You're either going to have, a greater than, less than, or a greater than or equal to, or a less than or equal to sign. So there's a little bit of a difference here. Now, what I want you to do is you kind of want to treat it like an equal sign, but I'll explain later. There's an extra step that we need to account for. So the first thing what we're going to do is we're going to bring everything to the left side. Now notice, a lot of people would think, oh, we just cross multiply up as if we're solving a rational equation. We don't do that in rational inequalities. Okay, this is very important. I'm going to write this here. Don't cross multiply. Otherwise, you're going to mess up the whole inequality. So what we're going to do is we're going to actually take this right side and we're going to bring it over to the left side. So let's do that. We're going to have x plus 3 over x plus 1 minus x minus 2 over x minus 3. And then now that we brought it to the left side, we leave this as greater than or equal to 0. And that's going to play an important part in the future when we get to the inequality aspect. Right now, we're just doing some algebra. So let's continue on. With the left side, what we got to do is we got to find a common denominator. So I'm going to multiply top and bottom by x minus 3 for the first term, and I'm going to multiply top and bottom by x plus 1 for the second term, because I want to make sure that the denominator is a common denominator, because we are adding and subtracting fractions. So we need common denominators. Okay? Now what we're going to do is we're going to expand out the top. So we're going to have x squared plus 3x plus 3x minus 3x, which is 0, minus 9. And then I'm just going to do this side as well. We're going to have x squared minus 2x plus 1x is negative x minus 2. And notice how I put these in brackets. The reason I put it in brackets is because if you just go straight into it, you might mess up the sign with this negative. But by having the brackets, we can do an extra step to expand out that negative to keep everything clean and within reason. So let's continue on. So now what we're going to do is we're just going to clean this up. Remember from last unit, I always said, anytime you can clean something up, do it early and do it often. And the reason why is it's going to make your life a whole lot easier down the line. If you clean up too late, you're going to make a lot of mistakes. So let's group these like terms now, clean it up again, x squared and x squared and negative x squared, they're actually going to cancel out. And then at the top, we're just going to have x minus 7 over x minus 3 and x plus 1. Okay. So this is pretty much all we did is just solve. Now, step 2, we're going to do something different. You got to identify the x-intercepts and the vertical asymptotes of this question. And I'm going to tell you why, because these are called critical points. The x-intercepts and the vertical asymptotes. How do we get the x-intercepts? How do we get the vertical asymptotes? This guy in the numerator is going to be your x-intercepts, and then these guys in your denominator are going to be your vertical asymptotes. So let's actually write those in. The x-intercept we know is going to be 7, and then the vertical asymptote is going to be 3 and negative 1. And this is really important because we're going to actually plot these on a number line. So let's plot it up on a number line. from negative infinity to positive infinity, we're going to have -1, 3, and 7. And this is where we're going to do the zone analysis. So let's go to step 4. Zone analysis. Now, some of you guys might be thinking, like, what is this guy talking about? What is zone analysis? I'm going to explain that to you guys right here, make your life a whole lot easier. So zone analysis is actually when we look at the actual function. So remember, the function right now is x minus 7 over x minus 3, x plus 1, greater than or equal to 0, okay? So what the zone analysis basically states is that we're going to look at these 4 zones, and we're going to take a number, just any arbitrary number within those 4 zones, and we're going to plug it in as the x term. And from that, we're going to determine if that zone is overall positive or overall negative. So let's look at an example, okay? In this first zone right here, I'm going to take a number. So let's say -10, for example. And I'm going to take this -10 and I'm going to plug it in here, here, and here. And we're going to find out, is the whole thing positive or negative? So if I take a -10 in the numerator, I'll have -10 minus 7, which is -17, which is a negative. Then -10 minus 3, which is also a negative. And then -10 plus 1, which is also a negative. So I got a negative over a negative times a negative. So overall, that would mean that it's going to be a negative over a positive, which means overall we're going to get a negative. Okay, so this right here is my analysis, and this right here is my overall. Okay, the reason I need to do the analysis to get the overall, because at the end of the day, in step 5, the overall is what matters most. Okay, and we're going to do that for each term. So let's look at from -1 to 3, the second zone. What are we going to take? An easy number would be to take 0. And then we're going to plug in 0 into those x values. So 0 minus 7 will give us a negative. 0 minus 3 will give us a negative. 0 plus 1 gives us a positive. Okay. Now, what is the overall? It's a negative over a negative times a positive, which is also a negative. So a negative over negative gives us positive. Right? Something you guys want to remember is positive times a negative is a negative. A negative times a positive is a negative. Positive times positive is positive, and negative times negative is positive. So you need to know this. Okay, cool. Let's go to the next one, 3 to 7. So we're talking about this zone now. So 3 to 7, I'm going to take a number. Let's say we'll take +5. If we take +5, what do we get? So if I take +5, I'm going to have negative here, +5. This is going to be positive and positive. So negative over positive times positive is a negative over positive, which is a overall negative. Cool. So I took the number 5, and then here from 7 to infinity, I'm going to take the number 100. Just a random big number. If I do that, I'll get positive over positive and positive, which means this is overall positive. Cool. Now, step 5, right, is we actually need to look at what is so we have to evaluate the inequality. And I want to actually mention something here that I forgot to mention in step 4. Whenever we label the number line, step 3, whenever we label the number line, we want to actually label what is an x-intercept and what is a vertical asymptote. And this is going to play a big part later on. Because x-intercepts mean that the graph actually touches that point. But a vertical asymptote means that the graph doesn't touch that point because it's an asymptote. And this is going to make a lot more sense when we do the final answer, because x-intercepts are always going to have hard brackets. But vertical asymptotes and positive and negative infinity will always have soft brackets. So the bracket type changes depending on if it's a vertical asymptote or x-intercept. So it's important to label that in your number line so you're aware. I'll actually relabel it here so we have it. Cool. Now, let's go to step 5. Step 5 says we have to evaluate the inequality. Now the thing is, in the inequality that we had, it says what is greater than or equal to 0. So this right here is really important because this is going to tell us, are we evaluating the overall zones that are positive, or are we evaluating the overall zones that are negative? So this greater than or equal to 0 is saying, where is it overall positive? It's asking us, where is this overall positive? And that's when we actually look at our zones. So we can actually state the answer. From -1 to 3, it's positive, right? And from 7 to infinity. Now 7 is going to be a hard bracket because it's at the x-intercept, and infinity is a soft bracket. So notice how I put these answers. This is where everything comes full circle. These soft brackets have to deal with vertical asymptotes. This hard bracket has to deal with an x-intercept. This soft bracket has to deal with a positive infinity. So it's important to know that you will lose part marks if you don't actually label the correct brackets. You will actually lose marks in these questions. So it's very, very important to understand that as you get into it. So those are the 5 steps. So let's try another question. I didn't even write step 1. Step 1, simplify. Okay, let's go down to another example. So example 2, we're just going to do this equation. It's going to be 240 over t plus 8 is greater than 20t over t plus 1. Okay, 240 over t plus 8 is greater than 20t over t plus 1. So let's go through our steps. So step 1, we know, is simplify. Okay, so let's bring everything to one side. So we're going to go 240 over t plus 8 minus 20t over t plus 1 is greater than 0. Cool. If it's greater than 0, we got to do the common denominator. So I'm multiplying this side by t plus 1. Whatever I do to the bottom, I do to the top. And I'm multiplying the other side by t plus 8. Whatever I do to the bottom, I do to the top. Whoops. Okay, so let's go into it again. We're going to simplify 240t plus 240 minus, and mind you, I open up that bracket just to keep my stuff neat, 20t squared plus 160t. And the denominator, we're going to have t plus 1, t plus 8. And then I'm going to evaluate the negative, so negative 20t squared minus 160t. T plus 8. Great. And then what we're going to do is we're going to clean this up a little more. So negative 20t squared plus 80t plus 240 over t plus 1, t plus 8, greater than 0. Sorry, I just forgot to write that in. Okay, cool. Now, in the numerator, I can see it's a quadratic, but I do know I can factor out a negative 20 from the top. So we can get t squared minus 4t minus 12 over t plus 1, t plus 8. And then from here, let's see, can we do some factoring? Yes, we can. So I can factor the top to be t minus 6, t plus 4. Sorry, t minus 6, t plus 2 over t plus 1, t plus 8. Great. Okay, greater than 0. Let's see if that's correct. Okay. Okay, now that we have this, we can do some other cool stuff. So let's actually find the vertical asymptotes and the horizontal asymptotes. Sorry, the vertical asymptotes and the x-intercepts. So let's look at step 2. You want to find the x-intercepts and the horizontal asymptotes. So the x-intercepts we know is 6 and -2 from the numerator. And then the vertical asymptotes are going to be -1 and -8 from the denominator. Great. So now step 3, we're going to do our number line. So our number line is going to be from -infinity to infinity. We're going to have -8, -2, -1, and 6. And mind you, remember, we're going to label the vertical asymptotes and we're going to label the x-intercepts. Great. Now step 4, this is where the magic happens. We got to do the zone analysis. So let's actually take this equation so we can have it visual and do the zone analysis. We're also going to take this number line over here, and we're going to do the zone analysis for 1, 2, 3, 4, 5 zones. Okay, so let's do this zone analysis. So if I take a -100, let's say I take -100, I'll have a negative from the -20, a negative, negative over negative, negative. So then I'll find the overalls at the end. Actually, I'll do it right now. So we have negative times a positive, which is a negative, over a positive. This is overall negative. Cool. Okay, let's go to the next one. From -8 to -2, the second zone, we're going to take -6. So you got negative, negative, negative over negative, positive. So the top, you got a negative over negative. This becomes a positive. Cool. Let's take -1.5. So we have negative, negative, positive, negative, positive. Cool. So we got positive over negative, which is a negative. Then let's take 0, because it's an easy number. We're going to go negative, negative, positive, positive, positive. So we got positive over positive, which is positive, and then we'll take 100, which is a big number. So we got negative, positive, positive over positive, positive. So we get negative over positive, which is negative. Cool. Now step 5, we're going to fully verify everything. So in step 5, we know that it's greater than 0. Therefore, it's asking us what is positive. Okay, so which zones are positive? Well, we know from -8 to -2 is going to be a positive zone. So, but it's going to be a vertical asymptote at -8 to an x-intercept of -2. And the other positive zone is going to be from a vertical asymptote of -1 to an x-intercept of 6. And this would be your answer. Now notice, this represents the vertical asymptote, this represents the x-intercept, this represents the vertical asymptote, and this represents the x-intercept. Now some of you guys may be thinking, what is this U symbol? This U symbol just means union. And all that basically means is like, it's equivalent to you saying and. Okay, so it's this zone and this zone. So hopefully, you know, these 5 steps are really making it a bit easier for you guys to understand how these questions kind of work. It's very, very simple. Let's just recap. Step 1, you simplify. Step 2, you find the x-intercepts and the vertical asymptotes. Step 3, plot it on that number line. Step 4, put it in and do the zone analysis. And step 5, actually evaluate the inequality. If you found this video helpful, guys, you know, feel free to share it to your friends. You know, we're really trying to grow this channel. I really appreciate all the support thus far. We just hit 60 subscribers, so that's a huge milestone for us as an organization. But yeah, I will see you guys in the next video. Thank you so much. Bye-bye.